Hello, my name is Joe, and I'm here in the Green Acres Forest today to talk to you about science. Now, science is a way of knowing things, and it's also a method. There's something called the scientific method. And today I'd like to talk you through the scientific method to show you how you can design an investigation to answer a question about the natural world. So, the first step in the scientific method is to ask a question, and that usually comes from observations that you've made. So, I've been observing trees lately and how moss grows on them. So, an example of a question you could ask, and my question is, does moss grow more on a smooth barked tree or a rough barked tree? You want your question to be very simple to answer, like it has a yes or no answer or an either or answer. You don't want to ask huge questions like, what causes trees to grow, or what are all the things that happen in the life of a butterfly? Those questions are much too broad. So, my question is just a simple one. Does moss grow more on this kind of tree, or does moss grow more on this kind of tree? Step two in the scientific method is to form a hypothesis, and that is just a prediction on how your question will come out. And my prediction is that moss will grow more on the rough bark trees and not so much on the smooth barked trees. Another thing about the hypothesis is that you sort of have to think about why you think that. So the reason I think that is because I think the rough barked trees will hold moisture in these little nooks and crannies, and that will help the moss grow. And then the smooth barked trees, the water will just dry up really fast in the sun, and then the moss will have no place to grow on the bark. So that's my hypothesis and a reason why I answered my hypothesis that way. Okay, so after you have your hypothesis produced, it's time to conduct your investigation, which is step three in the scientific method. Your investigation is going to be the process that actually answers your question. Is your hypothesis correct or not? There are lots of ways to make a successful investigation, but I'll give you 4 things you need to think about, and then I'll talk about those things in more detail later. The first thing you have to do is control your experiment. The second thing you have to do is rely on facts and measurements, not opinions. The third thing you have to do is randomize your experiment or your investigation. And the fourth thing is to replicate, and that just means repeat it as many times as possible. So I'm going to show you some tools that I have come up with for my protocol, and I'm going to talk you through my protocol. So when I was planning my protocol for my investigation, I thought of some tools that I would need, and I either found them or made them so that this would be more successful. So the tools that I'm using are a compass, and that is so that I can I can sort of choose which side of the tree I measure on without it being my decision. It's always going to be north, south, east, or west. It's not going to be me saying, oh, I think I'll choose this part because it looks mossy, because that wouldn't be random. Another tool I have is this stick, which is just going to tell me where to measure on the tree. I'm going to measure each side of the tree at the base and at 4 feet. Another tool I have is this circle with a hole in it, and that is so that I can just hold it up to the tree and say, that has no moss in it, or look, that has moss in it. That way it's not my opinion as to whether the tree has moss on it, because sometimes it might be like, well, I'm not sure whether I should say that has moss or no moss. This is going to decide for me, and that makes it a fact, not an opinion. So that's another thing I mentioned before. Another thing I'm going to do is measure each tree 4 times, and I'll show you that as we go. And then another thing another thing I'm going to do, I brought this dice so that I can roll it, and this tells me which tree to go to next. If I roll a 1, I'm going to go to the north to find the next tree. If I roll a 2, it's east. If I roll a 3, it's south. If I roll a 4, it's west. So that tells me not to just pick my favorite tree, but to pick the tree that the dice decides. That's called randomizing my experiment. All these things are to get rid of bias, because if I'm choosing which tree to measure, I'm biased. If I'm choosing where on the tree to measure, that's bias. So you want to get rid of all the bias and just let your tools decide what to do. So I'm going to go ahead and show you how to measure the tree as I designed this protocol, and then I'm going to show you my data sheet and how to write the data on the data sheet. So the first thing I do is go get my compass and go to the north side of the tree, which is right here. I've already figured that out before. So that's the north side. I put my circle at the base of the tree, and there is moss in it. So I'm going to put a yes on my data sheet for north and low. Then I'm going to go to north and high, no moss. So I'm going to put a no on my data sheet for that square. So after I've measured the north side of the tree and written that on my data sheet, I'm going to go to the other three sides of the tree, east, south, and west, and measure low and high with my circle at each place. Okay, so this is the last tree I measured. I measured as many trees as I could. That's called replication. The more trees you measure, the more sure you can be that your results are correct. I've just completed step 3, which is conduct an investigation. I'm now ready to do step 4, which is draw a conclusion. Is my hypothesis correct or incorrect? As I was collecting the data, I was writing it on this data sheet. And for each tree, I circled whether the tree was rough or smooth, and then I wrote yes or no, or Y or N, for each place that I measured on the tree. Yes, did the circle have moss in it? Or no, did it not? Then on the far right side of this data sheet, you can see that I have totaled up the number of yeses. And it's possible that I could have gotten 0, none of the circles had moss. It's possible that I could have gotten 8, all the circles had moss, or anything in between. So you can see how many trees I measured and kind of what I came up with. But that would be really hard to communicate to someone. So what I have done is summarize my results into a graph so that I can more easily draw a conclusion. Here is my graph. It shows each tree as an X, and it shows how many circles had moss in it. So if you look at this bottom X on the rough tree side, that is a tree that only had 2 circles with moss in it. The one right above it is a different tree, that had 3 circles with moss in it, and so on. So you can see what conclusion you might draw from this graph and from this data. The rough trees, the numbers tend to be up towards 8. And for the smooth trees, the numbers tend to be more down towards 0. So I would say that my conclusion for this is that my data that I collected supported my hypothesis. Remember, my hypothesis was smooth trees will have less moss than rough trees. Also, it's okay if your hypothesis is not supported by your data. That doesn't mean you did a bad job. That just means that was the answer. So after I draw a conclusion, step 5 is to communicate your results to someone. So I could write an article and put it in the newspaper. I could make a documentary and put it on TV. I could just present it to my coworkers so that they know more about moss and trees. But it is important to share your data and share your results, because that is how science works. The final step in your investigation is to ask a question. And you'll notice that that is the same as step 1. So I started with a question. Now I did this whole investigation. Now I might have more questions. I answered my question, but I might have other questions. So maybe my new question is it true? Have you ever heard that moss grows on the north side of trees more than south side of trees? Is that true? I could do that investigation. I could say if maple trees have more moss than oak trees. These are just more questions I kind of thought of as I was doing this. Maybe my investigation, and maybe by watching this, it caused you to ask questions about my investigation. And that's the cool thing about science. Every time you see some result of science, it can cause you to ask more questions, and that leads to more investigations, and that makes science cyclical. If you do some investigations, I would love to hear about them. Feel free to email me your results. And by the way, you don't need a forest to do science. Ants on a sidewalk, squirrels in a city park, they make great scientific subjects as well. Thank you for joining me today, and I'll see you next time here at Green Acres.